Alright, today we're going to be looking at the review for this test that is coming up on Monday. So numbers 1 through 3, they say evaluate each expression, round to the nearest 10,000ths. Okay, so these are pretty straightforward. They want us to use the change of base formula to put these into a calculator. Alright, so number 1, log base 4 of 15, that would be common log of 15 over common log of 4, and that's how we would put it into the calculator. So common log of 15 divided by common log of 4 equals, round it to 4 decimal places, so that would be 1.9534 for number 1. Number 2, same idea. Common log of 20 over common log of 7. And we got 1.5395. And then number 3 is just natural log. That's an actual button in the calculator, so there's nothing to do there except just put it into the calculator. So natural log of 4, we get 1.3863. All right, that 2 rounds up to a 3 because of this 9. Whoops. Because there's 9 next to it. Number 4, express as a single logarithm, aka condensed. Okay, so when you're condensing, we use the properties of exponents, the quotient, product, or power property. All right, and it has to do with combining them into a single logarithm. First, we check for numbers outside. There are no numbers outside, so we don't have to worry about that. And then we combine it into a single logarithm. Since they have subtraction in between them, that will be division when they're combined into a single log, so it would be log of A over C. Number 5, expand the logarithm. Okay, so we'll be expanding this. So right now we're looking at natural log of 5 times x cubed. So I can separate the multiplication there into natural log of 5 plus the natural log of x cubed. And we also don't want any exponents, so this exponent can come to the outside as multiplication. So natural log of 5 plus 3 natural log of x, or 3 times the natural log of x. Now that the logs only have one thing inside them, this has a 5, this has an x, then we are expanded. Solve. Round to the nearest 10,000ths if necessary. Check for extraneous solutions. Okay, so number 6, we have log on both sides here. So that means we can just treat this as not having log at all. And then we can just solve this for x. So we'll subtract 2x. And we get 5x minus 4 equals 10. We'll add 4. 5x is equal to 14. Divide by 5. X is equal to 14 over 5. And that would be our solution to number 6. All right, number 7, we first used the properties of logarithms to combine these into a single log since they're on the same side. So to do that, since they're added, we would multiply. So inside the log, we'd have 3 times x minus 10, which in order to multiply those, we'd have to distribute. So it's log base 2 of 3x minus 30 equals 4. And now we can solve this by changing the form. Okay, so if I change the form, it's in log form, change it to exponent form, the base of the log stays the same. which is 2, and then these two switch, so it becomes 2 to the 4th equals 3x minus 30. 2 to the 4th power, that's 2 times 2 times 2 times 2, which is 16. 3x minus 30. And then we can solve this for x. We'll add 30. So we get 46 is equal to 3x. And then we'll divide by 3. So 46 over 3, I'm not sure that that simplifies. 46, whoops, divided by 3. No, it does not. So we'll just leave it as 46 over 3. And that will be our solution to number 7. That's good. Number 8 and 9 solved, round to the nearest 10,000s. Okay, so number 8, we have 5 times e to the 2x equals 450. First, we isolate the base, so we need to get rid of the 5 here, so we'll divide by 5. So we get e to the 2x is equal to, I want to say 90. Yeah, 90. And then we change the form, so we change this to log form. So natural log, since it's a base e, switch these, so natural log of 90 is equal to 2x. And we can solve this by dividing by 2. So we get natural log of 90 divided by 2 equals x, and we can put that in the calculator to give us an estimate here. So natural log of 90 divided by 2 equals, round it to 4 decimal places, 2.2499. And that's our solution for number 8. Number 9, we have 3 to the x minus 4 power minus 11 equals 25. First, we want to isolate the base. 3 to the x minus 4 is equal to 36. And then we want to change the form here. So I will change this to log form. And when I change it to log form, the base will be the same as the base of the exponent. So this is base of 3. And then these two are going to switch sides. So base 3 of 36 equals x minus 4. I'll solve for x by adding 4. And remember, you can't combine this 4 with this 36. So we will have log base 3 of 36 plus 4 is equal to x. In order to actually calculate this, I need the change of base formula to calculate log base 3 of 36. So that's common log of 36 over common log of 3, and add 4 to that, and I'll get what x is equal to. All right, so I can put this into the calculator. So common log of 36 divided by common log of 3 is this. And then I add 4 to that, plus 4 is this. Rounded to 4 decimal places, so that 5 will round the 8 to a 9. So 7.2619. And that would be my solution to number 9. Now there is no problem for number 10. I took that problem out. But the 11 and 12, we are going to use the formulas that we learned in topic 2, or the which is the growth formula, y equals a times 1 plus r to the t, and then the decay formula, y equals a times 1 minus the rate to the t power. So number 11, a population of 60,000 increased by 2.5% each year. Find the population after 10 years. Okay, so this is increase, so this is growth. So we will use the growth formula, y equals a times 1 plus the rate to the t power. The rate here is 2.5%, which divided by 100 gives us 0.025. The time period is 10 years, and the beginning value is 60,000. Okay, so we just plug that all into the equation here. Y equals 60,000 times 1 plus 0.025, and that's to the 10th power. Okay, so we just need to put this into a calculator. So we'll do this first, and then raise it to the 10th, and multiply by 60,000. So 1 plus 0.025 raised to the 10th power, multiplied by 60,000, and then we will, does it tell us how to round this? No. So I'll just round it to the nearest person because we're talking about people. So 76,805. So that would be the population after 10 years, number 11. Number 12, a $20,000 car depreciates at a rate of 13.1% each year. Find the value of the car after 10 years. Depreciates, that would be decay. So y equals a times 1 minus the rate to the t power. In this case, a is the starting amount, which is 20,000. R is the rate, which is 13.1%. Divide that by 100, gives you the decimal, 0.131. And the time period is 10 years. Put this all into the formula here. Y equals 20,000 times 1 minus 0.131 to the t power. Okay, so we'll do this all using PEMDAS. So we do this first, raise to the 10th, multiply by 20,000. So 1 minus 0.131, this, raise that to the 10th power, this, and then multiply by 20,000. Since we're talking about a car, I'll round it to the nearest penny, so $4,911.65. $4,911.65. That car is not worth nearly as much as when it started. Alright, so that's the review for you, everybody. You will also probably want to look over your homeworks for this topic as well, because this review is very short, and there's a lot of different types of problems.